So the topic for this particular video will be class diagrams. And if you remember in our last video, we discussed about 14 different types of UML diagrams. And I explicitly told you that class diagram is going to be extremely important when it comes to low-level design interviews. Now you might have a question, hey, why do we need class diagrams? The answer is very simple. Imagine you have been asked to design a system. How do you convey your design? One of the ways is you write the entire code, or you write the chunk, like some chunk of the code, and you add it, like you back it up with some lines of text which explains what you are doing. Now that is something you can do, and that will mean a lot of pages, right? A lot of pages that you'll have to go through in order to understand your design. And if the stakeholders, now who are the stakeholders? The architect, the manager, the tech lead, could be anyone on the higher management. If they do not agree with you on any particular part of the design, they might ask you to change it. Now that will mean you'll have to rewrite the code, or you will have to change a lot of things in so many pages, isn't it? Now, is that a viable way? Because the higher management people do not have a lot of time. Also, you as a developer cannot, write the code again and again, depending on the changes demanded by the stakeholders. So thereby, this is not a logical solution. Like you cannot write the entire code right at the starting. Now, this is where you'll have to convey your design using the class diagrams. Okay, I'll have so-and-so class, I'll have so-and-so interface, and I'll define the relationships and everything within a single page or within maybe 2 or 3 pages, and I'll present that to my stakeholders. Now over there, they'll analyze it, and because class diagram is a convention followed by most of the developers. So everyone understands it, everyone will understand your design and give you feedback. Now, if changes are required, you can do it on a design level. Once your design is approved, after that you go into the coding mode. Do not get into the coding zone right at the start, because if there are changes demanded from the stakeholders, it's going to take a lot of time. So that is why the first thing is design it and present it through class diagrams. Specifically when it comes to low-level design, you'll have to understand class diagrams. The other UML diagrams can be used for system design, for product management and other things. But as of now, our entire focus will be on class diagrams. Perfect. So the first thing that we will be learning is the class notation. Okay, what is that? We have classes, right? How do we represent classes to the stakeholders? The way is, we write the class name at the top compartment. What is the compartment? I'll explain you. We write the attributes like the date, like the variables, something like a value, like string value, something like a string name, something like a double price. All of these are attributes. Now that will form the middle compartment. What is this compartment? Please hold on. The last one, operations, the methods that do a lot of actions. Let's say you're returning the total price. So double get total price. That's a method, right? That will form the bottom compartment of your class representation. Now, what is this compartment? Typically, whenever you're designing, you will be representing a class by drawing a rectangle. Yes. And the class name will go at the top compartment. The attributes will go in the middle compartment, and the operations will go at the bottom compartment. So if I have a class which is, let's say, product, so I'll write product at the top compartment, and then if I have attributes, they'll go to the middle compartment. If I have operations, they'll go into the bottom compartment. Now, do I write the attributes like string name, double price? No, there's a pattern to it as well, which we will be learning in the next phase. Visibility markers. Let's first understand visibility markers. Whenever we are defining attributes or methods, we write something like public, private, protected, all of these things. Now, these are access specifiers, which I've explained in object-oriented programming in depth. Please go back and watch it. I'm not going to explain it in this particular video. So if your attributes or methods are public, you will be using the plus marker. You will be using the plus marker. If it is private, you'll be using the minus marker. If it is protected, you'll be using the hashtag. If it is package protected, you'll be using this tilde or whatever you call it. Perfect. So these are visibility markers. Keep them in your head. Okay. Let's move on to understanding how do we represent attributes. Very simple. We have the visibility marker right at the start. Then we have the name of that attribute. Then we have the type, integer, double, string. And then we have the default value, if any. So imagine I'm writing something as double price equal to 0. This will be in the code. And I'm assuming this is public double price equal to 0. And this is what I'll be writing in code. But when I'm explaining this in terms of a class diagram to the stakeholders, I'll follow this particular pattern, which is visibility marker. It's public. So what I do is I pick up the plus visibility marker. Perfect. After that, I need to write down the name, which is price. After that, the type. What is the type? It's double. After that, the default value, if it has. So the default value is 0. So imagine if I have a product, I'll write plus, and then so that's a visibility marker, then price, then colon double, and then the default value. This is how you write attributes in the middle compartment. Again, could be a private, could be a protected, could be a package access specifier as well, but put it into the middle compartment. Whatever attributes you have, it could go very long. That is absolutely fine. Perfect. So you've understood how to present attributes in a class representation. The next one is, how do we represent a method? Again, the same format. We write the visibility first, which is the visibility marker. Then we write the name. Then we have the parameter list separated by comma. How is it separated by comma? It's similar to name, colon, and the type. This is how it is separated. Again a colon, and then a return type. So giving you a very simple example, if I write integer sum integer a comma integer b, and this is returning a plus b, the inside code doesn't matter, because on design perspective, the method's name should be defining it, because we will be following a single responsibility principle. So the method name should define what it is doing. So the stakeholders are not interested in your implementation details. They're interested what kind of designs you're using. Is it scalable or not going forward? So if I have to represent it, imagine this is private. So the visibility marker this time will be a minus. So I'll go ahead and write minus. The name is sum. So I'll write sum. The parameter list has two parameter list, which is a integer, comma b integer, and the return type is int. So this is how you will be writing it. It could have been void as well. So in that scenario, you will be writing void in the return type. Understood? If there are no parameter list, the parameter will be empty. So if I have to write it in the bottom compartment, it will be this sum, and then goes with a integer, comma b integer, and then a return type of integer. So this is how you will be writing the methods in the bottom compartment. In the last compartment, all the methods will get into the last compartment. Perfect. So now we know about the methods as well. This is about the class representation. What if we have interfaces? So with interfaces, everything is the same apart from the top compartment. So in the top compartment, this is what you'll be writing. You'll be using the interface stuff that I've written and then followed by the name. So if I have an interface like, let's say payment method, this is my interface. So what you'll be writing is, the top compartment will look like interface followed by the name, which is payment method. So that is going to be at the top compartment, and this is mandatory so that we can recognize that, okay, this is an interface. Understood? Perfect. So we know about interface as well. What about abstract classes? So how do I differentiate between a normal class and an abstract class? How I do that is by using this particular stuff and then writing the name. But be very careful, the name will be in italics. That kind of tells the stakeholders that, okay, it's an abstract class and the name is in italics. Perfect. What about enumeration, where typically you define enums, which has multiple types. So imagine I say enum and then I say payment mode. And the payment mode could be UPI, could be credit card, could be debit card, or could be anything else. Now this is an enum. So if you have to define an enum in a class diagram or in that perspective, you'll have to write this again, the same stuff in the top compartment, followed by the name, and then there will be no middle compartment. And the values would be like this. Over here it will be UPI, credit card, debit card with dots. Understood? That is how you will be defining a enum in a class diagram. So as of now, I'm assuming we know how to represent classes, interfaces, abstract classes, enums through class notations. So now, whenever you see a design and you see those boxes, you know what they mean, isn't it? Perfect. So the first step is done, because the first step is to identify what kind of classes I'll have, what kind of interfaces I'll have, what kind of attributes will I have inside the class, what kind of methods I'll define inside the class. So this is done because I'd have placed all the boxes. Now the thing is, who is depending on whom, or who is calling whom? We'll have to figure these kind of relationships in order to explain that, okay, from this class is called, or this class is implementing this particular interface. How do I define them? Now we define them through relationships. Got it? So do not worry. The first stage is done, that is drawing the boxes. The next stage will be relationship. But before that, let's understand the perspectives of class diagram. That's very, very important. So what are the perspectives of class diagrams whenever you're drawing boxes? How much of a detail should you share to the stakeholders? Again, it depends who is reviewing your design. First of all, there is something as conceptual perspective, where you represent the concepts in the domain. You don't dig deep, not a lot. Why? Because the stakeholders are business people, analysts. They will not understand things in depth. They will not understand private. They will not understand the return type. So for them, what you could do is you could have conceptual perspective of your class diagram. And how does it look like? A customer, I'm going to tell them, I'll have a customer class that places an order which contains a product class. So this is my class, customer class, places an order class which is containing a product, because business will understand this kind of language. If I start telling them about attributes, methods, will they understand? Obviously not, because they're not programmers. They're business people. All they care about is revenue, what's happening, right? So for them, you can give a conceptual perspective that, okay, I have a customer who's going to place an order and then which is going to contain a product. So in terms of your classes, you are going to define them. All right. Next is specification perspective. Okay. Who needs these kind of perspectives? Architects and designers. Focuses on the interfaces of abstract data type of your software. It's very, very important to focus on interfaces, because if you're going to just write classes, it's going to be very difficult to scale. So they're going to review your design. Okay, you have interfaces, you're following modularity, so that the code can be scalable, maintainable, and reusable in the future. So they will be focusing on what kind of design patterns you're using. So for them, what you could do is a specification perspective. And how does it look like? Something like this, where you can skip defining, okay, I'll have these kind of small attributes. I don't need to define if I'm going to use an integer or a double, like attributes, small variables. They don't need to know it. All they care about is, okay, this is the interface. It's going to have so and so methods. That's it. Who's implementing this? Okay, this is the class. This class is going to have so and so methods. They just want perspectives. They don't want in-depth stuff, right? So this is where specification perspective comes in. Let's talk about the next one, which is implementation perspective, where you describe how classes will implement their interfaces. Something like order impl will have a variable, and then it'll define all kind of public as well as private ones. Like if you have a public function and that's gonna use small private methods, right, in order to modularize it, you'll have to define it. Why? Because this is your implementation perspective, and this is important for developers, because when you're designing, you can look at it and you can say that, okay, this is going to be my main method broken down into multiple private methods, multiple private variables, all of these things, right? This is required for you, for developers. For someone like an architect, they don't want to know what kind of modularization you're doing beneath it, because those are more like implementation details. Understood? So that is what perspective of class diagrams are. And now you know how to represent class diagrams. The next one is we will be understanding the relationship between classes. So first of all, there are 6 types of relationships that we will be discussing. The first one is association. The second one is aggregation. The third one is composition. The fourth one is inheritance. The fifth one is implementation or realization. The sixth one is dependency. So a lot of times you might feel class A and class B has association as a relationship, has an aggregation as a relationship. So there can be multiple relationships, because it might just feel that, okay, this relationship is followed, this is followed. And if you're thinking that, you're on the correct path, because a lot of them will be seeming relatable, right? So let's first understand the definitions, and eventually when we will be designing systems, you will get to know. Okay. So the first one is association relationship, and this is represented by this particular arrow. So whenever you see this particular arrow, that means there is an association relationship. Now, what is the definition? This represents a uses a relationship. Uses a relationship. I'll explain. Between two classes where the class uses or interacts with the other. Very important. Uses or interacts the other. So basically, if I'm saying I have a user class, so you can define a class diagram for the user class. I'll not be getting into that rectangle hustle. And there could be a cart class as well. And there's a rectangle at both places. Now, if I'm saying the user is having an association relationship, I'm going to define it with this particular arrow, and the rectangle would be something like this. So this kind of, if you see this particular arrow in your design, that means the user is using the cart class. It's using it. Understood the definition of association? So whenever you see this, you know this, right? Because for a user, if you have to, understand, imagine it's a shopping website, right? And for an example, we can take, let's say Amazon. My bad, give me a second. Imagine we take Amazon. So when I'm taking Amazon, people are adding, items to their cart. So this cart is something which could be, let's say, a private variable. And then I could name the variable as cart, and I could use the cart class. And the cart is where we dump things. And inside the cart, we can have something like an item. Something like minus item, and there could be an item class. The cart is kind of using the item class. So you will see these kind of, arrows and other things. You'll have to understand where to give an arrow, right? So this was about the association relationship. Perfect. Let's move on to the next one, which is aggregation. And aggregation is represented with this particular symbol. What is the definition of aggregation principle? It is representing has a relationship. Very important. has a relationship where one class contains the other class, but the contained class can exist independently. What does it mean? Something like a menu item, right? Now the menu item could be anything, right? Let me give you an example. So I'll again draw two classes. At the end I had to draw these boxes, otherwise it gets very difficult to explain. Okay, perfect. So again I'll draw this one thing, that's the top compartment, then the middle compartment, and then the bottom compartment. Perfect. Now let's assume that this is my restaurant class and this is my menu item. A restaurant will have a list of menu items, isn't it? So what I could say is, okay, I'll have a public because the menu item has to be publicly accessible, and I'll call it item list or something like this. Item list, and I could be like list of menu item. Agreed, list of menu item. And then there could be methods, which I'm not writing as of now. And when I'm talking about a menu item, the menu item typically would be having something like a name. So I can have a plus name and I could have a string to it. And typically I could also have a price. So let's say price, and that would be in double. So as of now, just assume this is what the menu item has. Again, it can have its own methods. So what I mean over here is the restaurant is containing, has a relationship, has this menu item. But can the menu item survive on its own? Yes, it can. There could be a restaurant 1, there could be a restaurant 2, and the restaurant 2 can also have this particular menu item. So even if this restaurant is gone, the menu item can survive independently. Why? Because the menu item can be a part of someone else, some other restaurant. Understood? So in such cases, you will be seeing this particular arrow. Again, I'm very bad at drawing. So throughout the entire playlist, please forgive me for that. I'm not that great with these kind of things. But yeah, eventually if I'm able to explain you, that matters. So we understand aggregation relationship, isn't it? Now, you might ask me, hey, Straver, then association might be similar because a user can have a cart, some other user can have a cart. I will beg to differ over here because a cart is very specific to a user. A user can have a certain type of cart. Another user can have a certain type of cart. I can use the same cart class, but my cart could have different values, right? I could have different items into it. But with a restaurant, I can have a list of menu items. And the same thing could be used by someone else. There's a difference between has a and users a. So for this cart, I can have an instance 1, like an object 1. I could have an object 2 being used by somewhere else. So it depends, right? So this is why users a, and this is why has a relationship. Got it? Eventually, when we will be designing bigger systems, you will observe these kind of things. Perfect. Next one. Composition relationship. Okay, what is this? Life cycle matters. Over here, the life cycle matters. Let's understand. This is representing a very strong has a relationship. It's very much similar to the menu item, but it is a very strong has a. What does strong has a means? Where the other part cannot exist without the whole. What does it mean? Now over here, if I destroy the restaurant, the menu item can still exist and can still serve anyone else. But if I have the user cart and the user has a cart, if I destroy the user, the cart, the object of the class will also be destroyed. So this can also, like the association can, as I said previously, you may feel that, okay, this can also go in some other relationship. It's a call that you have to take. Perfect. So composition cannot exist without the whole part. A classical real life example would be, I'm in this particular 2 BHK building, right, or 3 BHK. And then I have the studio inside it, correct? If I destroy the entire building or destroy the entire flat, the studio will be gone. The studio cannot exist without the building. Got it? So that is the definition of A strong has a relationship. Got it? If the whole is destroyed, the parts are also destroyed. Got it? Now, example, order item. If I'm placing an order, the order class will have certain items, right? And when I destroy them, they're gone. They're gone because you need to understand over here, this order item could be like in different places. Imagine there are 5 units. And the order is of 5 units. Now this order item cannot be used somewhere else. Why? Because there were just 5 units. So it has a very strong has a relationship. Got it? So if I have to draw the class diagram, again the same thing. I can have the order and I can have the order item. And over here what I could do is, maybe I can have the top compartment and the middle compartment. Top compartment and the middle compartment. And then I can have this particular thing, which is something like this. Forget me for the drawing, and then we can just color it. So this is filled. Please keep in mind this kind of says that this has a strong. In the previous one, this was not filled. It means not strong. Now over here, I can have something as, imagine, plus units integer equal to, initially I had 5 units for any given item, or we can define the unit for any given order item. This is a class. We can have initially 0 units, or you can have methods like add this one, and all of these things could be done. But typically, if the order is consuming the order item, right? If it's consuming it, again, for that reason, I can have order list, and I can have it as list of order item. Over here, every order item that you include, the unit is gonna decrease. So it has a very strong relationship. If it's gone, the order item would increase, or if it consumes everything, it's gonna deprecate. So it's a very, very strong, has a relationship. Got it? Perfect. So we know about composition as well. 3 done. So the next one is inheritance. The symbol would be something like this. Please be careful that it's a filled arrow. Okay. You must have used this particular keyword, that is extends, right? Whenever you will be using extends keyword, we will be getting into inheritance. Let's understand the definition. This will be representing is a relationship where one class inherits the attributes and methods of another class. One class is typically called as the superclass, and the other class is called as the subclass. Keep that in mind. Let me explain. Now over here, if I take the example of payment method, this will be my subclass. Why? I'll explain you. So again, using class diagrams, we could typically draw the payment method. We can have a middle compartment, and then we can have methods. So we'll have the payment method as the class name, and then we'll have certain attributes and then certain methods. One of those methods is compute price, which is typically going to return a double. Again, there could be parameters, but as of now, I'm just trying to explain you the logic, so I'll not get into the depth. So compute price is a method, which is a public method, which is going to return a double type. Perfect. Now we have certain ways of making a payment. One of that is card payment, while the other one is a UPI payment. For the card payment, I could have one more class. So I'll draw one more class, which is for the card payment. Perfect. Oh no, not perfect. Maybe I can draw it again. I think this is perfect now. Then we have it for card payment. Again, same thing, 3 compartments. And then we have one more, which is the UPI payment. Maybe I can draw it. And then we have a top compartment and then a middle compartment. So when I'm saying card payment, typically we'll have a method. Again, and I'm not writing the attributes. We'll have a method which is, let's say, process payment, and it's a void method which is going to process payments. If I'm saying that there is a relationship, I'm saying that there is an inheritance. What am I meaning by that? That means I can use everything. That means I can use everything that payment method has. Now, whenever I'm going to write or implement process payment, you know what will happen? The process payment will first use the compute price, like what is the price. After that, I can have my logic for card. So I'll get the price, and then I'll implement my card logic. So this is where I'm inheriting a certain functionality of payment method. That is why inheritance relationship, and it's defined by this particular arrow. So whenever in the design you see this particular arrow, that means this particular class is gonna use the methods and attributes of the subclass. Over here, this is my subclass and these are my superclasses. Got it? So similarly, you can have a UPI payment as well, and it will have the same process payment, and thereby it's gonna also inherit this particular thing. Perfect. I think we have understood inheritance, and typically the extends keyword is used in order to inherit the attributes and methods. Next one, something like inheritance, I have taught in extreme depth in the object-oriented programming lectures. Please go back and watch it if you do not recall them. Okay, coming back, next one, implementation. Now this will be represented by dotted lines and a filled arrow. Okay, this is also called as realization. What is this relationship all about? It's between a class and an interface. Keep this in mind. Between a class and an interface, where the class implements the methods declared in the interface. Okay, interesting. We can have a notification service. Now this is an interface. So what I would typically do is, I would again do a class diagram. Okay, and then I can have this line. No, I need to have it slightly below. Why? Because for interface, if you remember the class notation, it goes as, you'll have to write this interface, and then you'll have to write the name, which is notification service, if you remember, right? And then you can have all your methods and all your variables listed in the middle and the bottom compartment. And imagine you have an email service. So what will happen is the email service would be standalone here, and then there would be a SMS service as the class diagram. And what you will do is, you will have dotted lines which is stating that you are typically implementing everything that notification service is telling you to implement. Similarly over here as well. I'm very tired, so I'm not going to write a lot more, but you understand the gist, right? If the notification service is asking you to implement a method like, send notification, you're going to implement that in the email as well as the SMS. In both ways, you can send a notification. So this particular arrow means, my bad, over here it will be an arrow. It's going to be arrow, 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 and then, okay, you get it, right? Perfect. So that was about implementation. Now coming to the last one, I'm assuming, yeah, this is the last one. Yes, this is the last one, which is dependency. This will be represented by dotted lines and an unfilled arrow, like normal arrow. Now this will be representing a user's relationship where a change in one class may affect the other class. Do you get this? Let me explain you. Now imagine I have a delivery service class. It's responsible for delivering items. Now inside the delivery service class, I'll be using some maps, because for me, if I have a rider, it's going to deliver one of the products of a customer. It will require the geolocation, and to go to that geolocation, it will require a certain map. Assume we are using a Google Map API. Now imagine tomorrow there is a change in the map service. there is a certain change in the map service that is going to impact the delivery service. If the map service is down, it's not working, the delivery service will be impacted because it cannot run without the map service. How would the delivery partner know where to deliver? What is the road? That's going to take a lot of time. So that is why if there is a change in one class and that affects the other class, if this goes down, this goes down. If they increase the pricing, let's say I'm probably going to increase the pricing on my delivery service as well. If they're going to update something, let's say they add more pin codes, that we're going to more and more pin codes, maybe I can add them into my delivery service. So similarly, you understand, like the dependency stuff. Whenever a change in one class affects the other class, so this is how you will represent. The delivery service depends on the map service, so the arrow goes towards the map service, but it's a dotted line, right? Perfect. So that was about dependency. Let's go back up. Can I say that I've done everything? Yes, the relationship has done, and that was about class diagrams. The next time, whenever you will be trying to convey your low-level design, you will draw all these kind of blocks, and you'll see a lot of arrows here, there, and you will have to remember what every arrow means. Specifically, the most used ones that I have used will be this one, inheritance, and typically association as well, or maybe a bit of aggregation. Dependency is okay, it's not that widely used, but yeah, typically you'll have to inherit, implement, associate, and aggregate. That's going to be very, very widely used. And eventually, as I will be solving interview related problems where I'll be designing systems, you will see me using these kind of arrows, and all of these things will get into your head. Do not panic as of now. So yeah, that will be it about class diagrams. What about the other 13 kind of diagrams? You can read through them by yourself, but those will not be important when it comes to low-level design. And because this is an LLD extensive playlist, I'll not be covering them up. You can read through them. That is something I'll leave up to you. But we will be focusing on low-level design solely in this particular playlist. I hope you understand that. And yeah, that will be it for this one. Thank you so much for watching.